Assalamualaikum and hi everyone. Today we would like to share about application of differentiation and we will discuss about related rates. Before that, I would like to introduce our group members. Firstly is me, Muhammad Faris Haziq bin Muhammad Fazil. Secondly is Amir Shahir bin Zaidi. And thirdly is Muhammad Rizan bin Marton. Now we will continue for our discussion about related rates, which is one of the subtopic in application of differentiation. Before that, we need to know what is differentiation. Now, I will explain to you guys what is differentiation. Firstly, what is differentiation? Differentiation is a process of finding the derivative or rate of change of a function. It has three techniques to solve differentiation. Firstly is a derivative of sum and difference. Secondly is a derivative of product function, or the other name is product rules. And thirdly is derivative of rational functions, or another name is quotient rules. It has 5 subtopics under application of differentiation. Firstly is related rates. Secondly is analysis of function 1. It have increasing, decreasing, and concavity. Thirdly is analysis of function 2. It have relative extrema, first and second derivative test. Fourth is have apply maximum and minimum problem. And fifth is a role theorem and mean value theorem. Now this is time for us to know what is related rates. Related rates is a problem that involves at least two changing quantities. Secondly, the question should ask to figure out the rate which one is changing given sufficient information on all the others. And thirdly, the idea is to find the rate of change of one quantity in terms of another quantity whose rate of change are known. Now it has 5 steps in solving related rate problem that you can guys follow it. Firstly, you can draw a diagram if possible. Secondly is label all the quantities mentioned in the questions. And thirdly is find an equation that related the quantity whose rates of change is to be found to be quantity whose rates of change are known. And fourth, use the change rules or implicit to differentiate both sides of the equation with respect to time. And 5 is a solve for the derivative that will give the unknown rates of change.
Hi, my name is Muhammad Rizan and I will present for the question 1. So, the question 1. The radius of a spherical balloon filled with air increased at a constant rate of 0.5 per second. Find the rate of change of volume of the balloon when its radius is 4 cm. Write in 4 decimal places. So, the first thing we need to do is to write the information from the question given before we get the solution. And the first is dr over dt, which is the radius of spherical balloon filled with air increase at a constant rate per second, which is 0.5 cm per second. And then we get the radius of the balloon, which is 4 centimeter, and we need to get the rate of change of volume, which is dv over dt. So before we find the rate of change of volume, we need to get the formula volume of spherical balloon, which is volume equals to 4 over 3 pi r cube. And then the second thing we need to do is to find the solution using implicit method. So the first thing we need to write is volume equals to 4 over 3 pi r cube, which is the formula of volume of spherical balloon. And then we need to differentiate it, and we get dv over dt equals to 3 times 4 over 3 pi r, 3 pi r power of 3 minus 1 dr over dt. And then we simplify it, we get dv over dt equals to 4 pi r square dr over dt. and after that we need to insert the information from the question given. So what we get is dv over dt equals to 4 pi times 4 square times 0.5, and then what we get is dv over dt equals to 100.5 cm cube per second. So therefore, when the radius of the balloon is 4 cm, the rate of change of the volume of the balloon is 100.5 cm per second. That's all from me, and I would like to give the presentation to Ami Shahir for the next question.
Hi, my name is Amir Shahid bin Zaidi, and I will show you how to solve the problem for the question number 2. The question states that the diagram on the right shows an inverted cone with a base radius of 5 cm and a height of 12 cm filled with some water. Water leaks out from a small hole at the tip of the cone at a constant rate of 4 cm cube per second. Find the rate of change of the depth of water in the cone when the height of water is 3 cm. So for the first step, we will bring out all the information given from the question. So the first one is dv over dt, which is water leaks out at the constant rate, which is negative 4 cm cube per second. Why negative 4? Because the water leaks out, decreasing. And the second one, the rate of change of the depth, which is dh over dt, when height, which is h, equals to 3. And then from the diagram, you can see that the radius is 5 cm and the height is 12 cm. Therefore, we will write it as a 12r equal to 5h. And then we find the value of r, which is 5h over 12. For the second step, we will use formula for volume of cone, which is 1 over 3 pi r square h. And then we enter the value of r, which is 5h over 12. Therefore, we will get 25 pi h cubed over 432. And then for the third step, we will differentiate the volume. The 25 will times by 3 and 3 will minus 1. Therefore, we will get 25 pi h square over 144. And then we enter the value of h, which is 3. And then we get 25 pi over 16. And then for the last step, we will use chain rule formula, dv over dt equals dv over dh times dh over dt. We will use all the information that we get from step 1 and step 3, which is dv over dt is negative 4, and then dv over dh is 25 pi over 16. And then we want to find dh over dt. Therefore, negative 4 will divide by 25 pi over 16, and we will get negative 64 over 25 pi cm per second. And that is how we solve the problem for question number 2. Overall, there is 5 conclusions. The first one is objective used in this problem are accepted. Second, the solution used to find the volume of related rates are succeed. Third, the application of differentiation is used to compute the rate of change. Fourth, the differentiation with respect to time or the other variable require application of the chain rule, since most problems involve several variables. And fifth, we must understand what is related rate and know that it can be used in our daily life. So that is from us. Thank you.